In this video, we want to write a polynomial function, p of x, having real coefficients with the degree and zeros indicated. So for this particular question, it says the degree should be 3, and the zeros that I have been given are x equals 3 and x equals 1 plus 2i. So x equals 3, that's a real zero, and x equals 1 plus 2i is a complex zero. It has that imaginary part, 2i. And the first thing we need to realize is that those complex zeros, they always come in pairs. Those are called complex conjugates. So there's actually a third zero that we were not given, but we have to realize that there is going to be a third zero, and it comes from the complex conjugate of 1 plus 2i, which would be 1 minus 2i. Those complex zeros always come in pairs. So now we do have all three of the zeros, which matches the problem requesting that the degree of the polynomial be 3. So now we're going to use our factor theorem and essentially work backwards from the zeros to create the factors. And remember, the factor theorem, when you know a zero, to create a factor, the factor will always be x minus whatever the zero is, whatever that zero value is. So in the case of x equals 3, then the factor is going to be x minus 3. And remember why that is. If we take the factor of x minus 3 and we set that equal to 0 and we solve, we see that we get the 0 of x equals 3. So that's why the factor is always x minus whatever the 0 is. So for the 0 of x equals 1 plus 2i, then our factor will be x minus that 0. But remember, this 0 has two terms. It has 1 as the first term and 2i as the second term. So we have to be sure to subtract both of them. That's why we need to put the 1 plus 2i in parentheses. So we're subtracting that entire 0, both of the terms, the 1 and the 2i. Then our third 0 is x equals 1 minus 2i. So our factor will be x minus, again, the factor theorem always says it's x minus whatever the 0 is. And then the 0 in this case is 1 minus 2i. We put that in parentheses as well. Now, it's asking us to write a polynomial function, and it specifically said we were going to call that function p of x. So we want to make this a function, so I'll label it as p of x is equal to these three quantities getting multiplied together. So this is the factored form. However, this problem is very specific and says that we can leave our function in factored form. It says factored, but factored over the real numbers. And remember, we have these imaginary pieces of this positive 2i and negative 2i. So we can't leave our function in this form. We need to go ahead and do some multiplication. We want to multiply this out. I'm going to show you a few different ways of doing this. I'm going to start with the second two factors, and we have subtraction. So I'll start by distributing my negative in both of those factors. So that's going to give us p of x is equal to the quantity x minus 3. And then distributing here will give us x minus 1 minus 2i. And then my last factor will be x minus 1 plus 2i. And here's where you have two options. And I'm going to show you both because I think it's important that you know there's more than one way to attack a problem like this, and you can decide what method works best for you. We have to continue multiplying, and we need to multiply these two factors. And there's two ways of doing it. The sort of longer method I'm going to show first, and then if you want to fast forward to the second method, you certainly may, is just to simply distribute. So our first term here is x, and we're going to distribute that. X times x is x squared. X times minus 1 is negative x. And x times positive 2i is positive 2ix. And now we're done distributing the x, so we'll move on to the next term, which is the minus 1. So we have that minus 1 times x, so that's negative x or minus x. Negative 1 times negative 1 is positive 1. And negative 1 times positive 2i is a negative 2i. We're done distributing the negative 1, and then we move on to the negative 2i, the last term. So negative 2i times x is negative 2ix. Negative 2i times negative 1 is a positive 2i. and negative 2i times positive 2i will be a negative 4i squared. So that's sort of by brute force, we are just distributing, but we're recognizing that each of those parentheses, those quantities, they both have 3 terms. So we just have to distribute very carefully. You'll notice that I color coded. I think that's a really smart way to visualize and make sure you have distributed each term and you haven't missed any. Then we're going to combine like terms. So let's see if anything combines. We have this x squared that doesn't combine with anything else. We have, you'll notice, a negative x and a negative x. So that will be a minus 2x. Then we have a positive 2ix and a negative 2ix. So those will subtract out. We also have a negative 2i and a positive 2i, which will subtract out. We still have this positive 1, so we'll have that still. And we still have this minus 4i squared, so we will have that as well. Now here it's important to remember the definition of I, the imaginary unit. I is defined as the square root of negative 1. And I squared, the square root of negative 1 times the square root of negative 1, is defined as negative 1. So these are really useful tools to help us simplify. When we have that I squared, we know I squared is negative 1. So this piece here, negative 4 times I squared, if I squared is negative 1, that will end up becoming a positive 4. So our polynomial function right now is x minus 3 times the quantity x squared minus 2x plus 1, and then this becomes plus 4. So we can see that's going to become x squared minus 2x plus 5. So p of x is equal to the quantity x minus 3 times x squared minus 2x plus 5. Now, if you are working on a problem that was requesting that your polynomial be in general form or sometimes called standard form, then you would continue to distribute this. However, this problem again says you may leave the function factored over the reals, meaning we don't want to have any imaginary numbers in our factored form. And you'll notice we do not have any imaginary numbers in this factored form. Remember, this is factored. It's factored because it's multiplication. So we have this quantity x minus 3 times this quantity x squared minus 2x plus 5. So this is the factored form of the polynomial, but it is factored over the real numbers. Again, this second step here was also factored form because this was multiplication and this was multiplication. The very first step was actually factored form because of the multiplication here and the multiplication here. So those are both also factored form, but those are not factored over the real numbers because of the imaginary numbers that are in the factors. So my final answer here would be the factored form over the reals. Now, if that method of distribution works for you and that clicks for you, then please stop the video. You're done. If you would like maybe a slightly faster or more efficient way, then listen on. You'll see I've erased some of my intermediate work, but I have kept my original 2 steps that are the same. That was using the factor theorem to create the factors. But now I'm going to attack this a little bit differently by regrouping the second and third sets of parentheses. You'll notice that in this parenthesis here and this parenthesis here, the first 2 terms are the same. They both have an x and a minus 1. So I'm going to get out my red pen and regroup this. I'm going to put another little set of parentheses around this x minus 1 and this one here. And the reason I'm going to do that is because now I'm going to treat these quantities like they have 2 terms. So I'm treating this x minus 1 as the first term, and then I have this minus 2i as my second term. And then in this quantity, x minus 1 is my first term, and then positive 2i is my second term. That's just a creative way to regroup this to make the distribution a little bit faster for me so that I'm not having to distribute basically a trinomial times another trinomial. I'm thinking of this as 2 binomials. So the x minus 3 hasn't changed, and now let's go through the steps of distributing. So thinking about if we're just going to multiply two quantities, basically like I'm multiplying an a plus b times an a minus b, just regular distribution, you know, first, outside, inside, last, what you all know, many of you, as FOIL, if you know that acronym. We can use that here because we're just distributing two binomials. So we have this quantity x minus 1, and we're multiplying it by the first here, which is another x minus 1. So that's just going to be x minus 1, the quantity squared. Then if we go with outside, we have this quantity x minus 1 times a positive 2i. So I'm going to reorder that and write the 2i first. So positive 2i times the quantity x minus 1. I know that looks ugly. Don't worry about it right now. Let's keep going. Inside, so now I have this minus 2i, and I'm going to multiply that by the quantity x minus 1. So minus 2i times the quantity x minus 1. And then finally, last, which is the minus 2i times this positive 2i, which is a minus 4i squared. Now, I know that looks ugly, but notice in the middle, the blue term is a positive 2i times x minus 1. The green is a negative 2i times x minus 1. So these terms are going to subtract out. Basically, the outside and inside subtract out. So now you have to multiply out the x minus 1 squared. Remember, that's just x minus 1 times x minus 1, which is fairly simple. So that's going to be the x squared minus 2x plus 1. And then at the end, we have the minus 4, but times I squared. Remember, I squared is negative 1, so that works out the same. That's negative 4 times negative 1, which is ultimately going to equal positive 4. So this is going to be plus 4. And you can see we end up with the same final answer, just a slightly different approach. Because obviously when I combine like terms, I'm going to end up with x squared minus 2x plus 5, which is exactly the factor I had in the end. So that's sort of an alternative way of regrouping instead of distributing a trinomial times a trinomial. And if that makes sense to you, please feel free to use that method. And if not, no worries. Go back to the original method I showed. It's valid. It works all the time. Good luck.